Hello and welcome to this session. So in this session we're going to be looking at how we subnet IP version 4 addresses, and this is how we basically achieve other networks from one network. And we're going to go through this by the two methods that we have, that is a classless interdomain routing and a variable length subnet mask. So let's get into this video. Now, if you're into this type of content, remember to hit the like button, comment down below, subscribe to my channel so that you're updated each time I upload a new video. Now, as I said earlier, there are two ways to subnet IP version 4 addresses. That is a classless interdomain routing, and this is when we have a requirement of networks and specified by networks. That is, you could be told to create 4 networks, 5 networks. It could be any number, but the requirement itself is the number of networks when it comes to classless interdomain routing. Now, in a variable length subnet mask, the requirement is the number of users in each network. That is, you are required to create different networks, but in each network you specified the number of users that you need to create for each network. So let's get into each of these methods and get to understand how we create networks through the two methods. Now, classless interdomain routing. So now, suppose you're told to use 192.168 and .1.0 with a prefix of 24, that is the network, and you're told to subnet this network to get 4 different networks from this. Now, in a 4 decimal notation of representing IP version 4 addresses, you have 255.255.255.0 as the subnet mask of this network. Remember, we have a prefix of 24, and 192.168.1.0 as the network in this example. Now, in binary octet form, remember, to subnet we need to change the number from 4 decimal notation to binary, and how we do this, I showed you how to do this in the IP version 4 addressing video. So go back into the IP version 4 addressing video and look at that, and then come back to subnetting. Now, when we present the network that we have been given in a binary octet form, we get the values as I have indicated them here on the screen. And but the reason of doing this is to identify the network part of the IP address and the host part of the IP address. Now, remember, you could be given networks with different prefixes, but the method is the same. Now, what helps us to identify the network part and the host part of a network is the subnet mask. And as you can see, for the subnet mask, in the network part we have all ones, and in the host part we have all zeros, but it could be different according to the value in the octet. It could be a 1, it could be a 2, it could be a 3, it could be a 4. So it depends according to the value that is in the host part. In our case, we have all zeros. Now, when we have this, then what we need next is our formula. Now, the formula for achieving subnetting using a classless interdomain routing is 2 raised to the power of n is greater than or equal to the number of subnets or networks that you need to create, where n is the number of networking bits required to be able to accommodate these 4 networks in that one network. Now, what we are going to do that and get 2 raised to power n, and it is raised to it is greater than 2 raised to the power of n is supposed to be greater than or equal to 4, and we increment n until the condition is met. So we are going to increment the value of n until that condition is met. Now we are then going to use the value of n to extend the network part in the subnet, and in our case we are going to get the value as a 64. Okay, so 2 raised to the power of n is supposed to be greater than or equal to 4. So if we raised 2 to the power of 1, it will not be greater than or to 4. If we raise it to 2, it will be equal to 4. So we are going to use 2 bits in the subnet to accommodate these 2 networks. Okay, and you can basically see the difference between the 2 subnets in the first slide and in the second slide, and you can see that the networking bits have changed from 24 to 26, and that is the subnet now that we are going to use in order to accommodate the 4 networks that we are required to create. Now when we do that, we are now going to take the 4th octet and represent it as we said earlier in the IP version 4 addressing video, and this is where we increment 1 until the 8th bit, and this basically helps us to represent 1 octet. Now we are going to take the value that is in the list in the leftmost part, that is a 1, and in our case it is 64. So we are going to use 64 as the increment number to divide this network. Remember, in 1 octet we can have a maximum number of 255 or 255 users. Okay, now we are going to use 64 to increment we are going to use 64 to increment or divide the networks, and when we do that we are going to get in the first network, the first the IP address of the first network will be 192.168.1.0 with the subnet mask of 26. The network, the second network will get the network address of 192.168.1.64 as the network address for the network. Remember, we're using the value of 64. So we add the 64 in the 4th octet until we get to 255. Now when we add the 64 to 64, we're going to get 28 and 128, and sorry for that, and that will be the network address for the 3rd network. And when we add the 64 to 128, we're going to get 192, and we are that is going to be the network address for the 4th network. Remember, in IP version 4 addressing, we have what we call as the first usable address, the last usable address, and the broadcast address. We defined this in the IP version 4 address addressing video, so watch that. And in the first network, the first usable address will be 192.168.1.1. that is the first IP address that can be given to a host in that network, and the last usable address will be 192.168.1.62, and that is going to be the last usable address. Remember, in IP version 4 addresses, I can't seem to skip to mention this, we have 4 types of addresses. That is the network address, the broadcast address, the first usable address, and the last usable address. So go and watch the IP version 4 addressing video, then come and attempt the others to get the first usable, the last usable, and the broadcast address of the 2nd, 3rd, and 4th network. So let's get into let's get into variable length subnet mask, and this is where we subnet according to the number of users we want to accommodate in each network. And this is basically done to avoid the IP address wastage. Remember that in a classless interdomain routing, we assign equal number of users in each network. Now, suppose you're told to use a 192.168.1.0/24, which is a prefix of 24, and you want to accommodate 120 users in the first network, 50 users in the second network, 25 users in the third network, and 2 users in the fourth network. Remember, we always start from the largest requirement of users to the lowest requirement of users. That is, we move from the largest network to the least network in terms of users. And the formula for variable length subnet mask is 2 raised to the power of n minus 2, and it's supposed to be greater than or equal to the number of hosts in each network. And the value of n is the number of host bits that we need to use in the subnet mask in order to accommodate these users in the specified network. Now, as I said, the formula for variable length subnet mask is 2 raised to the power of n minus 2, and it's supposed to be greater than or equal to the number of hosts in each network. Now, n is the host bits that we need to use, and we increment n until the condition is met. So in our 4 dotted decimal notation, we represent the subnet mask and the network address. And we said in order to subnet, we need to change from a 4 dotted decimal notation to binary form. And when we do that, we are going to get the values as I have represented them on the screen. And this basically helps us to identify the network part and the host part of the IP address. Now, VLSM, as we said, it tampers with the subnet mask. So in the subnet mask, the value of n is the number of bits that we need to use in the subnet mask in order to achieve a network that can accommodate that number of users. Now, let's get into the calculation, and we're going to start with the network with the highest number of users. So we're going to do 2 raised to the power of n minus 2. It's supposed to be greater than or equal to 120, and when we increment 1, we are going to get the value of n being 7 when we increment 1 in the value of power 2, and 2 raised to the power of 7 is 128. When you minus 2, you get 126, which is greater than or equal to 120. So we are going to use that 128 as our number. So in the first network, we are going to accommodate 128 users, and this can comfortably accommodate 120 users without any stress. So the 120, we are going to use 128 users. So from the subnet mask, we're going to take 7 bits, and when we do that, we're going to get a network with the first network having the network address of 192.168.1.0 with a subnet mask of 25, and that is basically the first network. And we have said that it can accommodate 128 users. So when we go to the second network, when we go to create the second network, we're going to start from 128. Okay, so let's do the formula again for variable length subnet mask for the second network. And this time round, 2 raised to the power of n minus 2 is supposed to be greater than or equal to 50. When we increment the value of n, we're going to go up to 6. And when we do 2 raised to the power of 6 minus 2, we're going to get 62. And 64 is supposed to be our value. Okay. because when you do 2 raised to the power of n, it's 64. Minus 2, you get 62. So we're going to use 64 as our value, or the number of users that we're going to allocate in this second network in order to accommodate the 50 users that we have for this network. So we are going to borrow 6 bits from the subnet mask, and when we do that, you're going to get a network with a network address of 192.168.1.128. remember, .128 was the last value for the upper network, or the first network that we created. So with 128, the .128 is going to be the network address for the second network, and we are going to go all the way to 192. Okay, so that is going to be the network address for the third network. And when you do the formula for the variable length, the subnet mask again, which is 2 raised to the power of 2, and 2 raised to the power of n minus 2, it's supposed to be greater than or equal to 25 this time round. And this time round we are going to get the value of n as 5, since 2 raised to the power of 5 is 32, and this will comfortably accommodate 25 users. So as I said earlier, the network address for the third network will be 192.168.1.192 with a subnet mask of 27, since we are borrowing 5 bits from the subnet mask in order to accommodate this network. And the other network, of course, it's going to be 192 plus 32. So in the third network, we're going to use the values up to 223, and the 224 will be the network address 192.168.1.224 with a subnet mask of 30. It's going to be the network address for the 2 users, since the 2 raised to power 2 minus 2 is going to give you 2. So we are going to use the other IP addresses from this one in order to get for the network. So that's it when it comes to variable length subnet mask. Thank you for watching this video, and see you in the next one. Peace.